Finally, we introduce multiple regression. So with multiple regression, the question is what happens when there is more than one explanatory variable which we want to use to predict the response variable. So now our equation looks like y hat, predicted y, is intercept b0 plus b1 times x1 plus b2 times x2 plus ... So we might have 2 or 3 or 5 or 10 different variables together which you hope will explain the response variable. That ought to make sense, that in the real world the price of a house isn't affected just by how big it is, but maybe by the number of bedrooms and how far it is from the lake and other things like that. So we want to use multiple explanatory variables to predict one response variable. And again, we're looking for the equation that predicts at best, meaning the smallest sum of the squared residuals. So in Excel, we use data analysis and then regression to get the multiple regression model. Separate screencast on how to do this in Excel, but here's an example. Maybe not. Here's an example. So this predicts the price of a house from its size and the number of bedrooms, and now we're talking about Bristol, not Cambridge anymore. So the output looks like this, which is pretty intimidating, but the only part we really need is down here. And so this is the part we need, and the way to interpret it is this, that the predicted price is 36,783, that's the intercept, plus 157, that's here, coefficients, times the total square feet, minus 42,073 times the number of bedrooms. So that's right here. Or if we wanted to write it more mathy way, y hat equals 36,783 plus 157 x1 minus 42,073 x2, and here you need to know that x1 represents the size for total finished square feet and x2 represents the number of bedrooms. Notice, by the way, something surprising going on here. This model suggests that if you fix the size of a house, then every extra bedroom makes the price of the house go down by $42,000. That sounds a little bit surprising, but think about why that might be. Why would you expect to pay less for a 2,000 square foot house with 3 bedrooms than with 2 bedrooms? Or 4 bedrooms than with 3 bedrooms? It has to do with the way that the number of bedrooms and the size of the house interact with each other. Normally, when you add a bedroom to a house, you make it larger. But we will see some examples in class. The important thing here to recognize is that maybe for the first time you're looking at a function, a y, which depends not on just one variable, but on, in this case, 2, and of course it could be many more than that.